Okay, hello everybody. We're glad to be here in DeepSec, and thank you to the organization for selecting our research. First, we would like to introduce ourselves. My name is Ivan Sanz. My colleagues are José Antonio and Álvaro Folgado. We are a young Spanish research group, and we met each other during a security master degree. We started researching about SOHO router vulnerability for a master thesis. Well, talking about our research, we had a main objective that was to evaluate the current security status of the SOHO routers. For that, we draw 4 lines. The first goal is to search for vulnerability issues. We select 22 of the most popular SOHO routers in Spain, but be aware that these routers are also sold in most countries, in more countries of the world. The second one is to explore new attack vectors, just to find new ways to exploit these devices. And then there are 2 more goals that are related with the security community. The first is to develop exploiting tools, and the second is to build an audit methodology, just to make it easier to future researchers to find vulnerabilities. Well, I would like to start talking about previous researchers. There's a lot of information. For example, some of them is UPnP hacks that belong to Armin Hemmel. Well, of course, it talks about, about hacking these services. Then the Petkov website, New Citizen, that talks about a large number of SOHO router attacks. Well, this is one of my favorites. It's the Craig Hefner blog site. He talks about interesting attacks like DNS rebinding or shared tools as being Walk, that is a firmware reverse engineering tool, or Miranda for UPnP audit. As you can see here, he's a bit angry with one of the manufacturers. This is a common problem that you will see later. Okay, this project is also really interesting. It belongs to Pedro Joaquín, and it gathered a large number of exploits for SOHO routers. In most of cases, you just need to press a button and hack. Well, this is a bit different. So hopelessly broken, it's a contest with the main objective of hacking SOHO router devices. And this one I'm pretty sure that you know about is Misfortune Cookie. This was a vulnerability of some months ago, and it affects to the wrong pager web service. Well, I'm pretty sure that you will be thinking, okay, why are SOHO routers so insecure? What are doing the manufacturers with all these vulnerability issues? Well, we actually think that's something like this. Okay, yeah, I'm going to start with, let me explain a real attack. This happened in Brazil. This is, as you see in the screenshot above, it's a simple script that exploits a cross-site request for vulnerability to replace the original DNS IPs with rogue ones, just for phishing purpose. In the second screenshot, sorry because I think this is a bit small, this is the crafted link that exploits the vulnerability. There is the default credential of the most popular router in Brazil, followed by the configuration for changing these DNS IPs. This attack affects more than millions of SOHO router devices of Brazil. Well, let's start with what we found during our research. First, I'm going to talk about the common security problems. First is services. There are too many. Most of them are completely useless, and that's due that it increases the attack surface. Some examples are Telnet, FTP, UPnP, that is insecure by default, or Tonki, that is a service that aims to share some files of USB storage with the network, and NetUSB, that is similar, but for usually in high-end routers. Of course, there is an easy way to solve this problem, is that replacing these insecure services with a secure equivalent. For example, Telnet with SSH, or FTP with SFTP. Second topic is default credentials. This is the problem of credentials that are public and well known for its model. That means that if you Google a specific router, you will find the default credential for every model. These are not randomly generated. That means, for example, in this diagram, you can see the default credential of the router that we analyzed. This, for example, 1234, 1234, admin. And the main problem is that the common user, due to a low technology knowledge, doesn't modify this credential. So it's easier to perform an attack. This topic is related with the last one. If you thought that it's bad to have, or dangerous to have the default credential, the problem is that usually there are multiple accounts. Also are the same, are public, so you can Google it and find the default credentials, and are useless for the user. Why they need more than one account. Also, these accounts are almost always hidden for end users, so they don't change this account, or even worse, they are not able to change because it's impossible. Okay, so as we say, the usability and ease of use security are far from objective. Okay, let me speak about the first vulnerability, common vulnerability. Bypass authentication just allows an attacker to carry out some router configuration change or some action without any login process. This vulnerability can be performed also either locally or remotely, and it's due to improper file permission or just service misconfigurations. The web configuration interface is really easy to perform attacks. For example, permanent denial service or some reserved default configuration settings. I'm going to show you a demo video just to see how simple it is to detect this kind of vulnerability and also perform an attack. Okay, this is this browser. We are connected to the router. This is the login prompt. We are going to access using the default credential. That is Vodafone. It's the name of an Spanish ISP. And as you can see here, this is the configuration of the router. We can see here the open, that is an open Wi-Fi security, the SSID is DSR. So the next step is to open a shell and just ping the router, just to check that it's alive. Well, let me show you this left button. It's in Spanish, but it's a reboot button. So we're going to open the WorldSuite app just to intercept the request when we press the button. So we press, and let's see. Yeah, you see here, the request is reboot info CGE. We are going to copy this request and then just drop the packet because we don't want to reboot the device yet. Okay, so now we are going to clear the cache because we don't want to be logged in the device. In the below video, you can see the lights of the router. And then we are going to paste. Well, you see here we are not logged in, so we are going to paste the request and press enter. So let's see what happened. Yeah, you can see the screen have changed. This says that the router is rebooting, and yet the light stop and the router have reboot. Okay, as you see, it's really easy to carry out attack of this type and also detect this vulnerability. You can, for example, develop a script to perform a persistent DOS attack. Also, this is not only with the buttons of the web interface. You can, for example, find another actions like restore info CGE that will reset the settings to the default. So you can use the default credential to access the router, for example. Well, this service, SMB, is used to share files between the user and the SOHO router and allows an authenticated attacker to download, for example, the entire router file system. That includes critical files such as etc password or FTP configuration, and also, that is even worse, you can modify that files and then upload again. So you change some of the setting of the router. This is due to erroneous configuration of the wildline feature. And you can see in the screenshot below, for example, in the left one, this is a common access, but just changing the command, you can access to the service without any login authentication. And then, for example, you can do a symbolic link and do wherever you want with the router. Well, Twonky, as I said, is a service that aims to share files between a USB storage with your network. That means, for example, computer or laptops. This vulnerability allows an attacker to manipulate the contents of this USB storage without any login process. For example, downloading, modifying, deleting, or even worse, uploading files. This is due also to a misconfiguration of the service. And you can see in the screenshot below how easy it is to access the service, just typing the IP of the router followed by the port that is 9000. And for example, watch or see every file inside the service.
Okay. Talk about cross-site request for vulnerabilities, in which an attacker is able to change any router configuration setting by sending a specific malicious link to the victim. There are multiple attack approaches to this one, because as I told you, the attacker is able to change any configuration setting. First, we can try to change the router administrative password, or even open a critical port to the WAN, or enable an already disabled service. But the main goal itself is trying to carry out a DNS hijacking attack, which is, as most of you probably know, changing or modifying the legitimate DNS server to a root one that the attacker controls, so that he is able to compromise the user's privacy, since all the DNS queries are being sent to the attacker server, but also to redirect him to a malicious website in order to further carry out this attack, or even inject a payload. And also he's able to build a botnet, among other things. This attack requires embedding the login credentials in this malicious URL, so that it is completely feasible to do it if those credentials have never been changed, which is extremely common scenario. Here you can see the common cross-site request forgery schema. First of all, we have the embedded credentials that we're going to try to inject, add the router IP, this stuff, and followed by the path to the resource we're trying to vulnerate, and the cross-site request parameters we're going to try to inject. So this is a common example of a DNS hijacking attack, get, and the parameters. Easy stuff, as I told you. However, it is really important to take into account that most modern browsers will show a pop-up warning message, such as this one, which just says you are about to log into the site of the router itself with the username 1234 or whatever username you are embedding. Usually, any user will click OK, and because they don't care, they don't know what they do. But the most used internet browser nowadays, which is Google Chrome, doesn't show this pop-up warning message, so the attack will remain completely hidden to end user eyes. Well, most of you probably noticed the link is kind of suspicious, right? Okay, this is where URL sorting services, such as bit.ly or tinyurl, come really handy, because they allow the attacker to obfuscate and reduce the length of the URL itself. So this goes completely stealth to user size. And besides that, these kind of services are extremely used across social networking sites, so it will go completely stale, as I told you. This attack could be also performed by creating a malicious website. Here you can see a sample source code, easy stuff. We will all the parameters, and we are just posting this, and it will carry out the configuration change. We also have cross-site scripting attacks. Everybody knows about this. Injecting malicious script code within the web configuration interface. We can perform this attack locally or remotely. If remotely, it would be completely analogous to cross-site request for your attacks because we have to embed as well these credentials and inject the parameter. There are two main goals on this attack. One is carrying out a session hijacking, which is stealing the administrator cookie in order to further impersonate him and carry out configuration changes. However, several router models do not implement an authentication based on cookies, so this won't be useful at all for them. But the other one, which everybody knows also about this, is browser infection. You can redirect by using a cross-site scripting to a malicious or website or something like that. You just write a window location, and you can redirect the victim to a malicious website, as I said. So it's really easy to further carry out these attacks, or even just pop a shell, not only in the router itself, but in the computer. So this is the common XSS. Everybody knows about this. So let's move on. Beef, some of you probably also know this tool. It's really handy because some of the input fields have a character length limitation. So this allows us to hook to link to a much more complex script file hosted by the attacker machine. So we're able to carry out more in-depth attacks. You can see here a common example, the embedded credentials, all that stuff. And we are injecting a script with source and IP domain, which is controlled by the attacker. We also have discovered unauthenticated cross-site scripting attacks, in which the script code injection is performed locally, but without requiring any login process. This is achieved by sending a DHCP request PDU containing the malicious parameter in the host name. And after doing so, the router will reply us back with a DHCP acknowledge PDU. And after that, the malicious script will be injected in the web configuration interface in the connected clients or DHCP list table. This is your common table that matches IP addresses, MAC addresses, DHCP list time, and the host name, of course. Here you can see some examples. We can perform these attacks by using a custom script, such as this one. Or we might also use a packet manipulation tool, such as Scapy, or even go simple, because we are really lazy, and just try to change the hostname of the machine we're working on, so that the next time the computer reboots, it will send the DHCP request PDU with the malicious hostname optimally. You can see here a WireSucker screenshot. We are sending the request with the hostname, sample XSS attack, and the acknowledge. And it will be injected in this table. It's in Spanish, but as I told you, it's really, really common in most routers. Sometimes it gets a little bit trickier, a little bit harder, because you can see more complicated, but we only just have to analyze the web page, the source code itself, in order to be able to perform these attacks. As you can see, it will work flawlessly, so no problem. Sometimes it is a little bit more complicated, you can see here, but works like a charm. So, okay. We also have vulnerabilities related to privilege escalation, in which a user without administrator rights is able to escalate privilege and become a super user. This is a perfect example on why having multiple user accounts is a really unsafe security practice, because, well, I will show you in this video demo. But they will allow us to escalate privilege. And as Ivan already told you, nobody knows about the existence of these user accounts, and they won't change or delete this. Sometimes they cannot delete even this user account. So we're going to log into the router FTP server, and we are going to use the user credential, which is, as I told you, a non-administrative account. We cannot perform any action with this account. So due to a misconfiguration of the FTP server, it is not properly jailed, we are able to download any critical file you want, such as the config.xml file, which just contains each of the configuration parameters of the router, including the credentials from all users in plain text, and the etc password one. You can see here where open the etc password, and common stuff. And right now we are grabbing the output of the config.xml file, and you'll see the funny thing. We have the username, user password that we use to log in, and the super username, 1234, super user password that we can escalate to. Router security is strong, a really good lie. So by doing so, any user will be able to escalate privilege. We also have backdoor vulnerabilities. Everybody knows about this. Hidden administrator accounts, completely invisible to the end users. And if an attacker happens to know these credentials, it will be able to perform any attack. So we discovered this kind of backdoors, username admin, and the password 4 digits, followed by the AeroCon string. These 4 digits are the last 4 digits for the MAC address of the router itself. So expect this backdoor to be present in even more routers. There's also another funny thing. There is an XML property called backdoor, so it gives you the hint. And we also have information disclosure vulnerabilities, which allow us to obtain critical information without a login process. This is another funny example of router insecurity because it is actually a router flooding the internal network or spamming, get request, you can see here, to a JSON formatted TXT file, okay? So if we check those TXT files, you see here, we get all the configuration settings for the internet. So security at the best. But we also might get a connected client list, or even the router gives you hints about the password, as you see here. It's default true. But this one is my favorite so far, okay? Because it shows you the SSID, the WLAN password, the WPS PIN code, so that you are able to connect to the router even if the WLAN password is changed. But as some of you probably already noticed, the funniest part of it is the name. Hidden info.html. So really hidden. And we're going to move on to those vulnerabilities related to the Universal Pre-Pay protocol, which is enabled by default on several router models. It was designed to allow applications to execute network configuration changes, such as opening ports. This is really important for video game consoles or peer-to-peer clients, which just open these ports to improve their stability and their performance. The problem is, it is an extremely insecure protocol because it lacks an authentication process so that not only the application, but also the user or any user is able to carry out these configuration changes, and it's often implemented in a terrible way, in a really terrible one. The goals are multiple: open critical ports for remote one host, carrying out a persistent denial of service, among other things. We may perform this locally by using a tool such as Miranda. This one was created by Griff Henner, really good stuff. And here we are carrying out add port mapping action that opens a port. And have a look at the third argument, this one, new internal client. As you can see here, we are opening a port for a remote one host. This is not supported by default by the protocol, but it is caused by an improper, well, the parameter is not properly sanitized, so we are able to do this. But we are also able to do this, a blind command injection attack. So really good security, as always. This attack could be also exploited remotely. There are multiple attack approaches to this, but I'm gonna just show you one, which is by using a malicious flash file. Okay, so the attacker hosts this malicious flash file in a web configuration server. So whenever a victim accesses this web server, the flash payload will be executed, and this flash payload will carry out this add port mapping action. Because, as I already told you, the applications have the permission to carry out these UPnP changes. So what is this useful for? Okay, it is extremely useful for carrying out local-only exploits in a remote scenario, because we are opening critical ports to the remote one host. So This allows us to carry out lots of attacks.
Ithaca?
Yeah.
Echo? Ah, good. Well, once we have spoken about the different vulnerabilities, I am going to speak about the position of the attacker at the hour exploited. The most common will be in the local segment. This is the most common scenario. For example, this Wi-Fi hotel or a Starbucks Wi-Fi or a Wi-Fi hotspot. And the second scenario will be remotely, where the searcher, the attacker can search for different vulnerable devices in the wide internet using, for example, Shodan. But if the attacker wants to expand the number of users that are attacked, he can use a social network like Twitter, and he can put some very attractive tweet like this famous lake of photos of some famous actress with a malicious crafted URL. He can, for example, use this photo. Well, if he uses this photo, I think that he is not going to have a lot of clicks, but if he uses Jessica Alba, I think that, congratulations, you are going to have a big bonded for you. But well, of course you can buy followers or retweet, this technique we know. To continue, I am going to do more or less this scenario with a live demo. Can you hold my microphone, Jose? Thank you. Well, I will do it locally because I cannot do it remotely because my router here, that is vulnerable to a cross-site request for your vulnerability, is not connected to internet. Then I will use two virtual machines. One of them will represent a legitimate DNS and a legitimate web server. His IP will be private and finished by 7, okay? And the second virtual machine will represent a fake DNS and a fake web server. And his IP will be finished by 6, easy. We can see right now that, that I have yes, it is here. That I have the IP, the DNS IP that corresponds to the 7. That means that I am a normal victim. I go to the browser and I load, for example, the page of DeepSec. It's no problem, it's working perfectly, nothing wrong here. But what happens if the attacker knows our email and knows that we have a vulnerable router to this kind of vulnerability? He can craft, if he wants, to a special email with saying to us to click in a special create URL, or you can see there. If we click it, okay, it will develop a cross-site record for you on our device. Of course, every people that reconnect to the network, okay, I do, will be changed his DNS. We can go here and see that in fact we have a different IP that is finished by 6. Okay, that's good. We are going to see what happens when we have different IPs. I am going to clear the cache because if not, it's not going to work very well. You know the browsers. Okay, I clear the cache. And okay. Well, yeah, okay. Well, I am a normal user. I only click a little email. I go to my web and, well, what is this? I think that is a little more colorful, but it's not good for me, you know? A lot of things can happen. Well, this is very dangerous because, well, the fail of one person in the local segment, you can provoke to change the DNS of everyone that connects to the routers. And that's very bad. Next, my colleague Jose is going to do a different demo. I try to start the different virtual machine because 3 virtual machines in one.
My laptop is kind of old and doesn't handle very well these 3 virtual machines, but it will be just a second. So what we're gonna perform is we're gonna exploit the SMB vulnerability that Ivan already talked to you about. That is caused by a misconfiguration of the SMB server due to the white links feature is not properly configured. So we're gonna exploit that, and you'll see what happens. Pretty funny stuff. So let's wait for it. Sorry for this. Okay. Yeah, you can see the funny host name for unauthenticated cross-site scripting attacks, script alert hacked. Okay, let's move on into it. Come on, people are waiting for you. Okay, so first of all, we're gonna check that we have a good IP address, yes, exactly, on the LAN segment of the router itself. And first of all, we're going to use the integrated SMB client for Kali Linux, and we're going to list of the shared services by this SMB server. So, okay, you can see here that there is an available service called storage, which is a USB share fault, but however, there is no USB connected to the device. So right now, what we're going to do is we're going to connect to this shared service. And as you can see, there is nothing in this directory, but due to this misconfiguration, we're able to create symbolic links to any part of the router file system. So let's do this. You see the link, okay. And as you can see, we can navigate through the entire router file system. We can, of course, download the etc password file, or even, I don't know, any configuration file that you want to, like this. This is a configuration file for the FTP daemon. So right now I'm gonna show you. Okay. As you can see here, this is password, easy to crack. These hashes are really easy to crack, but we don't need to crack them. And this is the configuration settings for the FTP server. So we are able to modify these configuration settings. We can, I don't know, set authentication to none or truth to no, and we are able to re-upload this to the router itself. You can see here, works perfectly. So by doing so, we are able to modify any configuration parameter of the router. So since we are Spanish and we are lazy, we've developed a SMB exploit that just will download the entire router file system. So these are the arguments, storage, and the link name. Okay, link D. Okay. And as you can see, it starts downloading the entire file system. Easy, really easy stuff. It will start to download it. Okay, you can see. I will just stop this because it will take a long time, but you get the point. So this attack could be also performed remotely. So here there are some dorks, so you can enjoy this. There are thousands of routers connected to the internet with this vulnerability. This is a Observa Telecom BH4032N, which is extremely used on Vodafone, for Vodafone users on Ireland and Spain. And as you can see here, lots of IPs show up. So I'm not gonna perform this demo remotely because it will be highly illegal and I don't wanna go to jail. But I will show you a video demo, just performing the same attack but with a remote IP. As you can see here, remote IP. We are connected to it and creating the link, and everything works fine as well. So enjoy. So right now, we're going to go ahead, we're going to move on, and we develop multiple tools. This one is a really handy script for authenticated cross-site scripting attacks. Just allows us to inject a custom host name as I told you, really handy for that. This one is for lazy people, just changes the hostname of the machine you're working on. Really simple script, nothing too fancy. And this one is the SMB exploit we just showed you. We have also contributed with the router pound project, so go check it out. Really nice website and has multiple vulnerabilities. So this is the funny part. Manufacturer response. So we sent to them from 2 to 3 mails on average. And as you can see here, spoiler alert, most of them are unreplied 7 months later, and the number of vulnerabilities fixed is nil. So really good news. 7 of those manufacturers didn't reply us at all. Okay, they don't care. 3 of them just told us that it was not their fault, it was ISP's one. Okay, and they said they couldn't do anything. I don't believe them, but okay. And there is a funny story with this last one, because we reported them multiple times, and they only replied back to the last email, telling that it was not their fault and they couldn't do anything. Okay, but 1 week after that, we fully disclosed the vulnerabilities because we already informed all the manufacturers, and they weren't willing to fix those issues, so we just fully disclosed these vulnerabilities with responsibility. And they immediately contacted us back. They were really angry, and they were like, well, okay, this is serious business. Why did you didn't contact us before? So really funny stuff. So we think this graphic didn't fit the reality of what we have experienced so far. And this one fits much more perfectly this experience.
Something wrong? Perfect. We have seen what manufacturers answered to us, but as users, we want to end with this, and I am going to give some advice. First of all, of course, change your administration password if possible. If there are another accounts, administrative accounts, try to change the password also or delete it if you can. Okay, update the firmware is always a good action, but only, of course, if the manufacturer release new firmwares. Of course, don't be tricked by URL or social engineering. And if possible, disable UPnP. I say if possible because sometimes you disable it in the graphical interface, but it doesn't work. Okay, well, if you don't use a service and you can disable it, do it. Okay, for manufacturers, first of all, try to listen what IT security researchers have to say to you, because I think that is important. Don't include useless services that end users are not going to use. And of course, try not to open ports in the outside, because we know that the wild internet is dangerous. And of course, if you can randomly generate Wi-Fi credential, what not to do the same with the administration account credential. Of course, try to change the HTTP protocols insecure for HTTPS, and if someone design a different alternative UPnP, more safe, it will be the winner, I think. Of course, fortify the device, try to filter every input that enter inside, even with the HTTP, develop a token for cross-site request forgery, and try to not to recycle every vulnerable service that are in the internet. I think that I have made it clear. We can work on it. And well, about the results, we have found more than 60 vulnerabilities in different 22 router models from 11 manufacturers. Here in this table, we can see the disclosed vulnerabilities per manufacturer. We see that the leading ones are observed with Contrail, Huawei, and Ampere. Next, we can see the vulnerability by types. Of course, like always, Web 1 are winning, but doesn't forget about the other one because they are dangerous and sometimes we can exploit remotely. I think that we can see all that. And this big table represents more or less our work. We have analyzed, you have the different router models that we have analyzed with the different vulnerabilities. If a router model doesn't appear here, doesn't mean that it's not vulnerable, only that we have not analyzed it, okay? Well, we post it in SecList, packet store, and media reacted in different ways, using news. Well, conclusion. In one question, has SOHO router security improved? Clearly not. And not because there's a lot of vulnerabilities that are easy to exploit and affect millions of users. I think that it's our to fix it. Please, do it. And now, For those one sleeping a little siesta, brief user, here's come a brief. In two questions. If I have a HP router, I am safe? No. You know, because we have made this talk. But a lot of you will say, okay, I have bought the last high-end SOHO router, I am safe. Well, normally this router has a lot of services running by default. That means that increase the attack surface, then you are screwed up in the same way. Okay, thank you for hearing us. Questions?
Still don't know how you get to the DeepSec testing website that was supposed to be private. Okay, so are there questions? No? Ah.
Have you checked alternative firmwares like DDWRT or OpenWRT or similar ones? And do you feel like this is a feasible option? I mean, it's mostly for the... it's more difficult for the end user to flash them, but often it's an option to flash an alternative firmware image instead of the original.
You mean the protocol tier 069 that is open abroad, or?
Have you looked into alternative firmware images like OpenWRT and similar ones?
Well, we didn't look a lot at those custom firmwares, but do expect to be vulnerable to some vulnerabilities, especially those related to the Universal Programming Protocol. You can check it out on the website. There are multiple vulnerabilities for both OpenWRT or DDWRT or even Tomato. So, okay, they are safer, I will say, because since, well, the community will try to fix those vulnerabilities, but expect vulnerabilities to be present in those routers as well. Not that many, but some of them.
So, more questions? None? None? Then, thanks very much.
Thank you.